Good evening, sir. Um, Today's topic is comparison. Fingerprint comparison, and we are having two modules on this. This module and the next module. Fingerprint comparison is the process used to determine if two fingerprints are made by the same person. The ridge characteristics, also known as minutiae, are specific features in fingerprint patterns that help in their identification. If you look at the screen, some of the most common ridge characteristics are on the screen. They are depicted here. For example, we have what we call core. This is core. The core is the center of the print. Now, you may be wondering that this is somehow by the side of the print. Yes, it's because this is not a full print. So at times you may have partial print where you don't have the full print. So this is a partial print and this is the core. Good afternoon, sir. And this is the core. Then we have data. Data is that triangular area where you have change of direction in the pattern. So this is our data here. Then you have pore. You have pore. Pore, they are like small dot or holes on the ridges where those liquids that form the impression where they normally come out. Then you have a data. A data is a ridge that is standing alone, like when you have an island in the midst of a sea. Also, we have ridge ending. Ridge ending is where you have where the ridge just stop suddenly. That is ridge ending. Then you have a bifurcation. Bifurcation is where a ridge forked into two. Then you have crossover. Crossover is where you have a ridge appearing to cross over to the other side over another ridge. So like when you have a flyover. So now these are some of the most common ridges, and we said that ridge characteristics is also known as minutiae. These are the fine details that we can use to distinguish one fingerprint from the other. So during comparison, what we are looking for is the high degree of similarity between the ridge patterns. If you have two ridge patterns, what you are looking for there is the how much of similarity do we have between the two. So, and also the alignment of this minutiae or the minutiae points. Also, we also call it Gatton points. Gatton point. So he said that after the man that discovered them, that's Gatton. So the Gatton points or the minutiae, their presence and their alignment as those things that you are looking for, and even the consistency in other distinguishing features, like maybe at times you may have some lines like this. This line is a result of injury, the scar that has rendered the ridges separate like this. You look at it, this line separate this one and this one, this one and this one, separate all this one. But if you look at it, you know that this is just a line that is just going. This is a line. This is a continuation of this line. This is a continuation of this line. But what really happened is that there was a time that there was an injury on the hand, and that one rendered that one not to be a continuation. But you can't call it a ridge ending. This is not a ridge ending. All these are not ridge ending, but they are continuation of their respective ridges or lines. But this one is a ridge ending. So now the process of comparison involves the collection of fingerprints, as we discussed in our previous modules. Then after collection of fingerprints, you move on to enhancement, because at times many fingerprints collected from crime scene, many of them may not be all that visible or clear enough to be read or to be used. So what you need to do is to enhance them, as we discussed them in the previous sections. So, and there are a lot of methods, but the one that is easier and very faster to use this day is to get the picture of that, the image of that impression, send it to your system, and there are some software that can use to make it more clearer to use. If they are taken, you take them as colored. You take them as colored, but when you set them inside the system, you change them to black and white, or to gray. You change them to gray color. Then after that one, you try to adjust the color so that it can be more readable if they are not all that readable before. So then after that one, you go into analysis. Analysis is this involves examining the rich characteristics. You examine all these characteristics, look at it, where they stay, where the position of each one of them, their alignment. Look at it very well. Then you use that one to determine if the print is good enough to be used, because at times you may not have enough characteristics, probably because of the fact that the thing has been smudged or messed up before it was lifted, or maybe during the process of lifting it was not properly done. So you have to consider that one. When you look at it, analyze it, and you see that most of the characteristics or the minutiae are not visible, or they are not readable, all you need to do is to stop it. So the work will stop there. But after considering the position, the present, the position, the alignment, and every detail that's supposed to be there, and you see that majority of them are okay, then you go ahead to the next step. So a fingerprint examiner makes that assessment by comparing details, including the shapes. You look at the shapes of the ridges or the lines, the thickness. You look at where the line split or not. At times the latent print are often partial, as I said. So you have to consider this one before you move on to comparison stage. In the comparison stage, what we do is this. You place them side by side. Okay, before I move on, I want to tell us that I will be discussing on how to compare two fingerprints both manually and automatically. Now, today is going to be manual. One thing I want to lay emphasis on is that as a fingerprint examiner, you must know how to do it manually, because at times you may not have access to what you are going to use, or even when you have access to the software that will help you to do the comparison, it is possible that you have some mistake, some error. But as a human being, you can detect, it is possible for you to detect this error and make necessary correction. Let's move ahead. Today we talk about how to do it manually. Then the next module is going to talk about how you can do it using software that will do it automatically. Now, you have to print. When you have to print, maybe you have questioned or unknown. The question or the unknown is the one that you don't know who deposited it there. Maybe at the crime scene, you don't know. You just saw that one. We lifted it because it's a questioned or unknown fingerprint that you suspect that the suspect left behind. Now, you have exemplar. Exemplar is the standard. It's also known as standard. Exemplar or standard is a reference print that you want to use to compare with the other one. Now, the standard or the exemplar may be inside the database, or maybe the one that was collected from an individual, maybe a suspect that you want to either confirm that he was a culprit or criminal, or we want to use it to exonerate him. And at times, it may be that the fingerprint is on a document, and we are suspecting that the fingerprint of the purported creator of the document has been changed. So, or probably the man who created the original document was not the one who owns the fingerprint. So that suspicion may make us to want to compare the fingerprint, the known fingerprint of the man, which we call exemplar or standard, to the questioned one, the one that we are suspecting is not his own. So it's either of the two, whether on document or the one that is that we took from or lifted from the crime scene. Now look at this at the screen. By our left hand side, we have standard or exemplar. Standard or exemplar, then we have the unknown or the question, the fingerprint. So we want to compare the two. The first thing for us to do is to see if they belong to the same group. And what are we going to use? We look at the pattern, the flow of the ridges. If you look at this one, the innermost ridges enter from the same side and they all go out of the same side. So from the same side they enter and they go out of the print from the same side. So this is a loop. And another characteristic of a loop is that this one has a data and also a core. If you look at this one also, if you look at it, the innermost ridges, they enter from one side and go out of the same side. So that means this one is also a loop because also it has a core and a data. So both of them belong to the same group. So we can go ahead and we can go further for our comparison. Assuming what we have, maybe the standard is loop and the question is arch, then we have to stop because you can't compare that. The two cannot be compared. They are not comparable. You can't compare arch uh, with a loop. That means, in fact, by the time you see that one is arch, the other one is arch, the other one is loop. It means they don't belong to the same the same finger. They don't belong to the same finger, so they are not from the same source. So you have to stop it there. But when they are of the same group, we have to continue. We have to go further. Now let's look at what you have here. We have data. We also have let's mark it. Let's mark our data with yellow. Look at it. This is our data. Then we have core here. Let's mark the core with another color. Okay, because we don't have much color, let's still use that one for the data. Let's use yellow for the core. This is our core here. Let's place our core here. Then if we are let's count the number of ridges to have the ridge count. We start from here. 1, 2. No, if this is our data, so you will not start counting from this one. We start from here. So as long as we have a space between the two, so we start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we not count this one. We not count the core, the innermost, the one that we place our core. So we have 9. So our ridge count is 9. We have 9 ridge count. This one also. This our data here. One, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 also. This is our core. This is our core. So we are between the core and the data. We have 9. We have ridge count of 9. Ridge count of 9. Then let's move ahead. Let's try to get bifurcation, and let's use red for bifurcation here. This is one bifurcation. This is bifurcation. This is another bifurcation. This another bifurcation. This another bifurcation. Oh, I'm sorry. Sorry for that mistake. So we are still looking for bifurcation. are looking for bifurcation. Yes, we have another one here. This is one bifurcation. This is a bifurcation here. This another bifurcation here. So let's leave that one because of time. Let's go for the other one. So also here we have a bifurcation. We have a bifurcation here. We have a bifurcation here. We have one here. We have one here. So we have one here. We have one here. Yes, there's one here. Now, if you look at what you have on the screen, if you look at this one, here we have 1, 2, 3. We have 1, 2, 3. So the distance between here and here are the same. We have three ridges between this one. We look at this one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This from here to here also 1, 2, 3. This one 1, 2, 3. So this one 1, 2, 3, 4. That's 4. 1, 2, 3, 4 also. So we have the same thing. If you look at this one, we have one here. So we have one here. That's 1, 2, 3. That's 1, 2, 3. So, and we got another one here. No, this is ridge ending. Ridge ending just look like a yes. Let's look for ridge ending now. Let's use green for that. Let's look for ridge ending. This is ridge ending. It's ridge ending. Another ridge ending. Another one. Yeah, that's the ridge ending that is visible to us. Yes, this is another one here. Let's go to this place. We can get the same thing. Yes, this is ridge ending here. And this is another one here. So by the time you look at this one, these are perfectly from the same person. This is from the same person, the same finger. So we have to determine the number of points of comparison and the quality of fingerprint. The quality of fingerprint must be, you have to look at it when you are about to do your comparison. If the quality of fingerprint is not okay, you may not see what you're supposed to see, especially the quality of the questioned one, the unknown. If it is not okay to the exemplar, and the exemplar also must be okay. If the exemplar in the database, or the exemplar that you have taken from a suspect, if it is not well done, if it is not well taken, then it will affect the result. So both of them must be adequate in quality and also in quantity. Even though partial print can be used to compare with a full print of exemplar, but if that partial print is too small, then it will be it won't be adequate. It won't do the job. So it must be adequate in quality and in quantity. Because of the fact that fingerprint analysis or fingerprint examination is not an exact science, therefore at times result may be subjective. That is, one or two things can affect your result. For example, cognitive contamination can affect the result of a fingerprint examination. What I mean by cognitive contamination is when you already knew that a suspect, due to another form of evidence, you have some other evidence that confirm that he was never in the crime scene. That one may affect the job that you are doing, because already it's like you have the result and you are working towards the result. So because of the fact that this is not exact science, then the best thing is, after you might have done your work, let another independent examiner look at it, so that the two of you can conclude and say, yes, this is what this is correct, or one of them may look at it and say, no, what you have done, something is wrong with it. You have to redo it. There are three possible conclusions. Excuse me. There are three possible conclusions for the results of the examination. The first is identification. That is, when you have a match, you compare the two and you know, and you can see, you're able to determine that both of them are from the same source. That means the match, and in that case, you are able to have identification. Then another one is exclusion. Exclusion is when you compare the two and you discover that both of them are not from the same source. So that is exclusion. That is exclusion. Then, and the third one is inconclusive. When perhaps one of them, maybe the unknown, doesn't have enough detail to be compared with the standard. In that case, your result is going to be inconclusive. Or perhaps maybe the fingerprint are on document, and on the document what they brought to you is photocopy of photocopy. Maybe some generations of photocopy, and the lines, the ridges are no more showing. The details are no more showing very well. Then in that case, by the time you look at it and you conclude that this photocopier, the photocopier machine didn't do the right work, or maybe it has been as a result of several generations of photocopy, then what you have to tell them that the result is inconclusive, because you cannot conclude, you cannot use what you have to do the job. So the result is inconclusive. And there's some other factors also may play in that will make you to have inconclusive. If the standard is not of good quality, then there's nothing you can do. For example, the one that you have, the existing one, or the one that was taken from the suspect was not properly done. Maybe the ink was not properly done. or the machine was faulty. So it will be difficult for you to have identification or exclusion. In that case, you are going to have inconclusive. We are going to stop here today so that next week we can start from another example that will be totally different from this one. This one we have identification, but in the other one we have example that where we not have where we have exclusion. So thank you. We are meeting in the next class on Wednesday by 4 p.m.